Hey Sanjay, hi Vivek, good morning.
Hi, Jagat. Good morning.
Good morning, Vivek. Good morning, Jagat.
Good morning, Sanjay.
Good morning. My screen is visible?
Yes.
Yeah.
Okay. So we have to start today, guys. Load balancer. What is a load balancer? Elastic load balancing. So elastic load balancing is a feature of EC2 service, right? You can find in this EC2. But what you can do with load balancer? What is the purpose of load balancer? And why we are using load balancer? The first of all, let's say you have an application and that application is running. That application can be internal and that application can be internet facing. And if that machine is facing too much load and it is not sufficient basically handled to load, one machine is not sufficient to handle the load, in that case the picture of load balancer comes. Actually, this load balancer is responsible to distribute load among target instances. And what are the target instances? Target instances are the instances registered within the target group to receive the traffic from the load balancer. This is the thing. So this is the load balancer and the traffic is coming from the internet or from any other application. And this load balancer will send or will distribute traffic one by one equally to all these registered instances in the target group. Right. Now, the load balancer basically automatically distribute incoming application traffic across target instances. And not only you can use target instances here, instead of instances, you can use IP addresses. You can also use containers. You can also use Lambda functions here as target instances or the target points. Here you can use containers, you can use IP addresses, or you can also use Lambda functions. So means between Lambda functions can also be this load balancer can also be deployed. Okay. So, but if you talk about the type of load balancer in AWS, we see four type of load balancer. The first is application load balancer. Second is network load balancer. Third is classic load balancer. And fourth is gateway load balancer. So we'll talk about the first of all, what is the application load balancer. So application load balancer, basically it works only on port number 80 and 443. So this is a restriction. Means application load balancer will work only these two protocols or port numbers. Protocols are HTTP and HTTPS and port numbers are 80 and 443. And it works on layer 7 of open system interconnection, or it works directly on application layer, you can say, right? So this is the one thing. But if you need to know more about application load balancer, so I did write here. So this will give a little idea of means how actually application load balancer is different from other load balancer, and application load balancer is best suited for these use cases. Application load balancer basically distribute your content on the distribute the content, right? Or it distribute basically the traffic on the basis of content. Application load balancer can route incoming traffic based on the host or the path of the request, making it well suited for applications that have multiple services running on different subdomain or path. For example, just assume what I'm trying to say with this line. For example, you have one separate server for images, one separate server for database, and one separate server for video clips. And you have an application. And the person who is accessing the application from the internet, he does write a URL. And in that URL, you need to see a specific image. and image is basically stored in a separate server. So this load balancer will route your traffic to that particular specific server, not to the all server randomly. No, it will find where this particular the content you can find. So that request will be routed to that particular server, image server, right? So it route basically on the basis of content. It also supports SSL connection, and few more things like it does uh, supports access logging. Access logging means ALB can provide access logging that includes information such as client's IP, request path, and response status code. So all these things that you can basically on the basis of this AWS load balancer can route your traffic. So application load balancer is the best load balancer if your application is internet facing. Number one, application load balancer is the best load balancer if you have a web application or a website that people want to basically access it over the internet. In that case, you should use application load balancer. This is a good load balancer for microservices architecture. In microservices architecture, generally, we do not run entire application on one server. So we have a multiple components of that application. And behind the application server, we have a set of APIs. And APIs here will basically take a responsibility to route your request to a specific container or specific virtual machine. So what I'm saying, if you have a microservice architecture and your application is internet facing, here also you will use application load balancer. And application load balancer is the only load balancer available in AWS which has an integration with WAF. WAF stand for Web Application Firewall. So firewall is responsible to filter incoming traffic, right? And you know that the maximum threat you find when the people are accessing your application over the internet, and you want to secure it. So in that case, you can implement web application firewall. So web application firewall can be connected with application load balancer to protect your application from any external threats, right? So those threats we'll talk about later because WAF is a separate service, but this can be integrated with application load balancer. This cannot integrate with network load balancer. So this was the basically the latest information we have about this application load balancer. And let's see what other changes are there, because this is a very dynamic, actually, all these things. AWS is making very frequently these changes. Next is network load balancer. In network load balancer, you do not have any restriction about any port number or protocol. It does support all logical ports from 1 to 65,535. So these are the number of logical ports available. So it will work for all logical ports, all protocols. Just assume where the network load balancer is needed. See, for example, just assume that you have a load balancer, right? You have a load balancer, and in this load balancer, behind the load balancer, let's say a set of application servers are running. These are the application servers, right? And this load balancer is distributing traffic to these two machines, right? This is okay. This is the front end tier. This is front and tier. I'm talking about the multi-tier application here. Their application is in a multi-tier. And behind the load balancer and behind these application servers, let's say you have a set of servers. Let's say these are the set of application servers, the other application servers, or you can say these are backend servers or backend tier, right? And here this was the application load balancer because it will face internet traffic. But behind this, actually this tier or the layer of servers, actually these servers needs to access some data from these backend servers. Right. The backend servers can have some application servers, some your database servers, and these servers will work on some different protocols. Let's say it's working on 6666, and this will work on some other ports. Let's say I'm assuming that like we are not using port number 80 here, we are not using port number 443. We have some other port number, and this application is running on this particular port number. So one thing is very clear. So whatever the load balancer you will put here, this load balancer will not work on port number 80. This load balancer will not work on port number 443. So one thing is very clear, ELB will not work here. So instead, what we are doing, we have to put NLB, network load balancer. So here the network load balancer you will introduce. And this network load balancer is basically receive traffic from this front-end tier, and this load balancer then further will distribute this traffic to these load balancer. So in this diagram, you see a two type of load balancer. One is internet facing load balancer. These are internet facing load balancer, right? The first one is the internet facing load balancer, correct or not? And the another is internal load balancer, internal load balancer. This is the internal load balancer. This will not receive any traffic directly from internet. So we have two type of load balancer architectural point of view in multi-tier application. So here we are using network load balancer, and network load balancer is also very, very important. Let's say you have some infrastructure. Let's say this is the one network you have, right? You have another network. Let's say this is the one VPC, and you have identical VPC, exactly, right? Identical VPC to provide high availability, and you need to distribute actually the load. So what I will do, we can, with the help of an IP address, let's say here we can put one IP address, right? This is the IP address. This is the, for example, is an IP address, and this another IP address is linked with the another VPC. So, and if you want to distribute traffic between these two VPCs, in that case, the network load balancer will come in picture. Network load balancer. Because the network load balancer is providing very high performance. It provides high performance. It is known for high performance. But it is different from application load balancer. Let me tell you how it is different. So I did write few lines about network load balancer here. These are the network load balancer is best suited for gaming purposes, for streaming purposes, for the protocol that requires the session persistency. If you need a session persistency on a specific machine using an protocol or IP address or some sort of TCP/IP or TCP or UDP protocols, in that case, NLB is required. And these are high performance web applications. If high performance web applications are running, you can use NLB. The NLB can also be connected. NLB can also be connected with internet. Why? NLB can also be connected with internet directly. But ALB cannot be used here between the layers of server, because ALB will work on port number 80 and 443. But NLB has no restriction. I told you the NLB can support from all logical ports like 65,535. So it will support all means all possible port numbers. So it does support the port number 80 and 443 as well. So if your application is really need high performance, in that case, you can place your uh, load balancer and network load balancer. And it is good for Internet of Things and some ICS. ICS is called Industrial Control System, just like DCS. distributed control system. We know it as industrial control system these days, like in steel plants or urea plants, or in maybe some let's say aluminum plants. So means, or you can say some the car industry. So where the number of robotic things or the other components are running on the on that particular plant, and you need to distribute load on those components. In that case, NLB can be used here. This is very rare, so generally IT people are not using this. This is very specific to some plants, right? But in short, you can understand, if you need a high performance, if you need a connection persistence, and if the data is you find in streaming or for the gaming purpose, so in that case you can choose NLB. Otherwise, if your application is a web application server or a website, in that case application load balancer is recommended. Now see here, in this diagram I just described actually the two type of load balancer. One is internet facing and another is internal load balancer. And one more thing is there, the application load balancer, when you configure this application load balancer or network load balancer, after configuration, this load balancer will have one endpoint, because you know that your applications are running on these target instances, and these target instances are identical, then only there is a use of distributing the load, right? So these target instances are 100% identical in real-time environment. And this load balancer will distribute traffic between these instances. So, and every machine will have an IP address. So how to access that application from the internet? So we are not using IP addresses of these servers. We will use endpoint of the load balancer. So once you configure this ALB or application load balancer, so this ALB will provide you endpoint, or you can say DNS of the load balancer. This is a kind of a URL to reach these applications running in these machines, right? So you will use endpoint of the load balancer to reach this machine. So public IP address is not mandatory to provide on these machines, and you don't need any static IP address on these machines. You need only IP addresses to reach this application servers, and ALB will do that. And one more thing, application load balancer or network load balancer, whatever you're using, so these load balancer does check the health of target instances. For example, these two machines are working on port number 80, right? So this load balancer, after a certain point of time, after a certain frequency, let's say in every 30 seconds, this load balancer will send a test packet to this particular machine. You're going to say heartbeat, right? So in every 30 seconds, it will try to basically check the health of this instance, whether this machine is working on this protocol or port number or not. If it is not working, it will stop sending any packet or any request to these instances. So it means, in short, we can say that application load balancer or network load balancer, whatever you're using, these are responsible to check the health of target instances. And these load balancers are connected with security group, just like your EC2 instances, to filter the traffic. So here we have an additional security group that you will configure with this load balancer to pass the traffic, right? And here you can also connect WAF. What is WAF? I told you WAF is a web application firewall. This is your WAF, web application firewall. Let's say this is the WAF, and this WAF can also be connected here to filter the traffic, to stop all kind of threats to these machines, right? But this is not free of cost. You have to pay additional money, because this also is a complex. You should know what kind of a rule you are applying, what kind of a threat you want to stop. So a number of ready-made rules are there, and if you want to customize your WAF rule, you can also customize WAF rule here. So this is very, very important security point of view. So your application load balancer should have this WAF. So I think now it is clear. So if you configure the load balancer, the first of all, it is connected with the security group. It can be connected with WAF, and in behind you will have number of instances in which this load balancer will distribute the traffic, and it is responsible for health of the target instances. If the instances are correct, if the instances are healthy, then it will forward the traffic. Otherwise, it will not forward the traffic. And by default, load balancer is using round robin algorithm. A round robin algorithm means the one request will go to this machine and the second request will go to this machine. And we have other actually algorithm also to distribute the traffic. I'll show you at the time of configuration. And few more features are there. But before that, I think we should take one simple diagram to just configure it. If you have any question, please tell me.
Good. I'm good, Sanjay.
Yep, good. Yes.
Good. Okay. So, uh, the first of all, whenever you apply load balancer, you have to select the which load balancer is more suited for your application or for your environment, right? Application load balancer or network load balancer. Just keep one thing in mind. If your server is a web server or web application server or internet facing server running on port number 80 or 443, it means you have not to think much. It means the application load balancer will work, right? Because the network load balancer will not work with WAF. So till now, so till yesterday, WAF was not connected. So I need to confirm it because I have no idea what they are doing, what change they can do. Okay. So first of all, I'll create two machines in two different availability zones, of course, in the same VPC. The machine should be in a two different availability zone, and I'm taking only two machines. You can have in the target group, you can have 3 machines, 5 machines, 10 machines, 20 machines, but I think the two machines are sufficient. Why? I'll tell you later. Because we can also integrate auto scaling with these instances, right? Let's say one instance is not sufficient, so automatically the second instance should come automatically and join this target group right here. So that's why we do not create much target instances. I think the two target instances, two different availability zones are sufficient. So, but this integration of auto scaling, we will talk about later. Here, we are just concentrating on application load balancer. So I'm going back and see, this is my North Virginia region, and I'll open EC2, right, and see where is my notepad. Notepad. We have a notepad. Oops. No, no. Okay. What I'll do, just let me see. I use a script to configure my server. I'll not configure my server step by step. That will take time, right? So yesterday, actually, this Miro was down. Oh God, we had no class. This was down yesterday. Oops. Do we have any script? Yes, we have, I think. We have the script. No, this is not the script. This is not the script. We pause the script. Just a minute. Right. Yeah, just I'll pass that script to you. Hash bang bin bash. Yes, this is the script. This is the script, the first of all, because when you run a script, you always start that shell script, Linux shell script with hash bang bin bash. So first of all, we have to update our operating system. Then we will install HTTP package, and then we will start this HTTPD service. We will enable HTTPD service from here, and then we will create a one index.html file in where www.html, and this is the content of my index.html file, right? And let's say this was I was teaching to ANZ. Let's say this is my web server, or web application server, web application server, and let's say this is a server 01, right? And here is the configuration. You are changing ownership of index.html. You are changing the permission of index.html. And what did you write here? You did write only one line here. And I think this is okay. And if you want to change, that is, I think, the sufficient, right? This is okay to just understand whether this application will work or not. So what I'm doing, I'm copying this script here, right? And I'll go back to my EC2 page. Here I'll launch my instance. As you see, we do not have any instance. Click on launch instance. Let's say this is my web server 01. Web server 01. T2.micro is okay. AMI Linux is okay. And key pair, definitely I have to create a key pair here. Let's say this is my yes, server link key, and let's say this is 6th December. I'll remember this. Great. And this is my download, and I'm just downloading this key. And here in the network setting, I'll choose my VPC. This is the VPC. In subnet, I'll choose US East 1A. Public IP address, for now it is enabled, but if you want to keep disabled, that will work. And here is the security group. Let's say this is my Yash web app security group 01, right? Then here we go, and we need to enable HTTP traffic from anywhere from the internet, right? And if you see, the very last option is advanced details. I'll open this and I'll go the last option. This, you will find this option, user data, which is optional. Here you will paste that script. Here you will paste that script. This script will configure this machine as a web application server. So even in real-time environment, you should have one script to configure your server if you're dealing with large number of servers, right? So you have not to take the means remote to configure those machines. But please ensure that the whatever the code or are written here, these are well working. So you can first of all check on this some machine, right? And this is okay, and you can just launch this instance. So once the instance is launched, you will just test and verify that everything is working properly or not. So this is the machine. So this is the first machine I created. And similarly, now I have to create another machine in different availability zone, because this machine was in US East 1A. Now I'm creating one more machine, web server 2. Launch another machine, click on launch instance, and here is web server 02, and the other things will remain same. The key, I'll take the same one. Network setting, this time I'm taking US East 1B. This is another availability zone. Public IP address is enabled. And in the security group, right? So we have an existing security group. You can choose that security group. You have not to create security groups again and again. And if you go down, you can see this advanced detail. You'll go to the same box and you will paste the script. But this, in this script, I want to make a little change. The background color should be, let's say, little different so that you can understand from which server you're getting response. So I'm putting pink here, light pink. Okay, this is done. And the server name is basically 2. This is the second server. And you launch the instance. And this is launched. So we have 2 servers. And let me check one by one both servers. You can see this server is ready now. So this is the public IP address of this server. What I'll do, I'll open a new tab and put this IP address and press enter. Is it working or not? That we have to see. It's working fine. The background color is green, and I can see this line, web application server 01. So this is working fine. And this way, the second server we can also check. So this is the second server. Let's say this is second server, and this is the IP address of this server. I'll go and I'll paste the IP address of this machine and see this will work or not. That will take a little time. I think it is not yet configured. So if you refresh it once again, definitely it will take time. Okay, I think this will work. Yeah. So you're getting response from both these servers, right? So I intentionally made actually these configuration little different so that you should identify from which servers you're getting response. Now we have 2 servers and both servers are running in different availability zones. So these servers I will use in my target group of load balancer, right? These are the target instances. Now you can consider these are the target instances. And now if you go down, so you will see a feature called load balancing in this left hand side navigation, and click on the load balancers. Click on the load balancer. As of now, there is no load balancer. So you will create a load balancer. We have a 3 type of load balancer. One is application load balancer, second is a network load balancer, third is a gateway load balancer. So in which circumstances you can use a gateway load balancer? This is very, very important. And it says that it can be used only for third-party virtual appliances that support Geneva protocol. You know what is a Geneva protocol? Do you have any idea what is a Geneva protocol?
No.
Geneva protocol is a protocol which is being used with third-party intrusion prevention system, intrusion detection system, or third-party firewall like Palo Alto firewall, Cisco firewall, Fortinet firewall. Let's say in your infrastructure, you do not want to use AWS firewall. You say, no, we are very comfortable with the third-party firewall. We have very good experience, and we were using actually since many years actually this Cisco firewall or Fortinet firewall. So we will use Fortinet firewall or IDS or IPS, because AWS is not directly providing IPS or IDS. Those are really expensive. So you want to introduce third-party IDS or IPS, intrusion detection system or intrusion prevention system, to secure your application in your infrastructure. So in that case, you can use this gateway load balancer. So gateway load balancer is not only, we are not using gateway load balancer to distribute traffic or regular traffic or application traffic to instances. No, we will use gateway load balancer to distribute filter traffic, or it's basically the for filtration point of view, right? So in architecture, if you want to introduce any third-party firewall, in that case, you will use gateway load balancer. But for now, here we have an application load balancer and network load balancer. But where is that classic load balancer? We had a fourth load balancer as well. If you go a little down, you can see this is a classic load balancer. So actually, it is almost discontinued. We are not using it actually. This is the previous generation of load balancer, and AWS says that we should not use it because we have better load balancers here. For application, we have application load balancer, and for network activity on multiple protocols, we have network load balancer, right? So still, if in your organization some legacy load balancer is being used and you want to continue with that, you do not want to change the configuration of your existing infrastructure, in that case, you can use this classic load balancer. You can continue with the classic load balancer, but it is not recommended now. So here we have application load balancer, and you can click on create. We need to write the name of the load balancer. Let's say this is my application load balancer, ELB. We have a two type of load balancer, internet facing load balancer or internal load balancer. For this, actually, this is my application load balancer, and it will receive traffic from the internet. So I will use internet facing load balancer. We have two type of IP addresses. One is IPv4 and IPv6 as well. If you have both IP addresses, IPv4 and IPv6 in your infrastructure, in your machines, in that case, you will choose dual stack. Otherwise, you will go with IPv4. So generally, for your internal machines or private machines or your instances will have IPv4. And this is the VPC which will participate in load balancing. In one region, you can have multiple VPCs. So from here, you can choose your VPC. And here you will choose number of availability zones that will participate in load balancer. So my machines are running, one machine in US East 1A and second machine is running in US East 1B. So I'll choose only two availability zones from this network mapping. And if you go a little down, we have a security group. I told you, application load balancer has an option to connect a security group. If you do not have a security group here, either you have to create a security group, because I already have a security group and the security group name is Yash Web Security Group. So I'll choose this one. The same security group you can choose, right? Or if you need a separate security group, you have to create a security group, then you will choose it from here. Now, this is very important, listeners and routing. To whom you will route your traffic? Definitely to a target group. And the target group will have a number of target instances. But you didn't create any target group as of now. So you have to create a target group first. So to create a target group, because if you see, you do not have any target group. So first of all, you have to create a target group. You will click on target group. It will open a new tab. It will open a new tab. Now you are in a new tab. So, and now you are going to configure target group. First of all, you have to specify the endpoint. So endpoint is basically instance here. So my end resources instance. So I want to distribute my traffic to instances. Or you can choose IP addresses, Lambda functions, and further application load balancer. If you have load balancers in a nested way, in that case, you can choose application load balancer. Otherwise, then instances you will choose. So we do not have any option to select containers here. Do you see? So because we have a different service, ECS, Elastic Container Service. So once you have a load balancer and you want to introduce containers or you want to connect containers with a load balancer, through the ECS you can do, right? Or you can use IP addresses. So here for this particular target type, I'll choose instances and I need to write the name of the target group. Let's say this is target group 01, right? And on which particular port number you want to distribute your traffic. So on this listener, you can choose only one type of protocol or port number, right? If you have another port number and protocol, it means you must have another target group. So here we cannot use multiple protocols. We can choose only one protocol, either HTTP, HTTPS, TCP, TLS, UDP. Here we have a Genie, but we are using what kind of a load balancer? Application load balancer. And the application load balancer is specific to HTTP and HTTPS. So I'll choose HTTP here, and HTTP is basically for port number 80. And here we'll go, and no other configuration I have to do. I'll talk about health checks later on. And finally, you just click on next. So when you click on next, you will see your list of instances. These are available instances. You can register them to take traffic from the load balancer. So you will select these instances. You know that these instances are running in different availability zones. And once you select these instances, very important point, you have to press this include as pending below. Because right now, if you see the target instance space, in this target instance space, you don't find any target instance, right? Means no instance is registered as the target instance here. So you will click on include as pending below. As you click on include as pending below, you will see that these two instances are in this table. And once you see these instances are in table, now you can click on create target group. So your target group has been created, right? This is the target group and this is responsible for the health check. So right now it is saying it is unused. Why it is saying unused? Because your load balancing configuration is not means completed. And to complete this load balancing configuration, you will go to the previous tab. I was in basically previous tab. So you will click here and I was here actually, right? And if you refresh it, this time here in this list of target group, you will find a target group. This target group you created. You will select this target group and if you go down and if everything is okay and simply just click on create load balancer. The load balancer has been created. You can view your load balancer. You will see that the load balancer, this is the end point of the load balancer. Or you can say it's a kind of a URL of your application. This is a new URL of your application. You will use this URL to reach your application. This is known as DNS name, or sometimes we call it as a load balancer endpoint. But right now it is provisioning, so it will take little time to provision, right? In the meantime, we can do one thing. We need to check the health of target instances. So if you want to check the health of target instances, left hand side under load balancing, we have a feature called target groups. You'll go back to target groups. Earlier it was showing that the target group registered instances were not healthy. But if you go down, you can see that so it is still initializing. It is still initializing. So it is going to check the health of these instances. And this is the server 1 and this is the server 2. And these are the server IDs or instance IDs. Everything seems normal, right? Everything seems normal. But in a few seconds, few minutes, once your load balancer is configured, so it will show the status of your instances. You should see here healthy. What? Healthy. So right now it is under configuration. You'll go back to load balancer and you see that it is under provisioning. So that will take time. Once it is provisioned, I will use this load balancer endpoint. I'm copying this load balancer endpoint in your meeting chat. You can see that you will copy this or kind of URL, right? This is a URL, right? So once it is configured, you will test whether this is working properly or not, or load balancer is distributing your traffic or not. You need to check and verify. But here it will take a little time. Okay.
Yeah, URL started working. Maybe here is going
Yeah. Yes. So I can see this is the URL, and if you press enter, so you got actually the response from the server too. But if you refresh the same URL here, right? I'm refreshing the same URL. So now you're getting response from the first machine. If you keep refreshing, you will see that you're getting response from both the servers. Am I correct or not? Are you getting the same result at your
Yeah.
end?
Yes.
So it means the load balancer is working.
Yep.
So this kind of a load balancing has multiple advantages and multiple disadvantages. Now, just talk about some kind of you know challenges. Say, let's say here I'm talking about. So right now, actually, a user is accessing the load balancer. Means user is accessing this application through the load balancer, and his traffic is basically shuffling between these two machines one by one. Correct or not? So this load balancer is sending your request sometimes on to first instance A, sometimes to server B. But let's say you don't need this kind of a load balancing. Let's say you have an application that needs some data from user. Maybe you are filling some form, maybe you are paying some online transaction or online money. So in that case, the connection persistency with one server is required for a specific time. Correct or not? Let's say you are paying some money, you are purchasing an item online, and once you purchase that item, you want to pay you want to pay money through some online transaction. So during that time, even if the screens are changing, so actually the connection from the server should not be changed. So you need a stickiness. So right now, I was not using any stickiness. So you need a stickiness to a specific server. You needed this kind of connectivity. Let's say this user needs to pay something. So it means this session should be sticky to some specific server, right? So what you will do, it means we have an option called stickiness, and you have to enable it to provide a stickiness to a specific server for a duration of time. That may be in seconds, that may be in minutes, that may be in days, depend on the what kind of application you are running in these servers and what kind of task actually this user wants to do. So let's say he wants to pay some money through online transaction. So we need at least 4 minute, 5 minute persistency on this particular server. So we need a persistent connection on this particular machine. So we need a stickiness. We call this feature is known as stickiness. So how we can configure a stickiness? So you will
Uh,
go back to
just
you're
just
saying
wait for a couple of minutes.
yes.
Jagat, I think, is dropped from the call.
What happened?
Maybe router restarted.
Okay.
I just pinged him.
I can see he's not online.
Yeah, he just pinged me. He's joining back.
He's running. No, let him join.
Yeah.
Hmm. It's okay. Can you listen to me?
Yeah, I'm sorry, Sanjay. Yeah, my laptop, I don't know what happened. It the screen gone down, then I have to reboot again.
Not an issue. So we need a basically sticky session with a specific server or with this load balancer server, right? So how to configure this stickiness or the sticky session with the load balancer? So what you will do, you will go back to your load balancer screen here. I'm in the load balancer right now. And if you see, this is my load balance. And we have multiple tabs below here. And the one tab is attribute. Can you see here? You click on attribute. And if you see the attribute, we have multiple options like traffic configuration, Right now, we do not have any firewall where, right? We are running HTTP service on this, and ideal timeout is 60 seconds for a one session, which is very, very less. But if you see a little down, I don't see any option for the stickiness. So in the load balancer, we don't have any option for the stickiness. So what you will do, you will click on target groups, left hand side, and this is the target group you are using with the load balancer, right? So you will select this target group and you go to attributes. In options you can find, and in attributes you see that stickiness target selection configuration. So right now the stickiness is off. It means doesn't provide any stickiness with your servers, and you want to make some changes in this. So there is an added button here. Click on added button, and here you go. Right, we have a multiple traffic configuration, we have multiple load balancing algorithm. So by default, a round robin we were using. We have least outstanding request, and these are the new, actually. This is the new one, weighted random. So generally we are using round robin. And if you go a little down, here the stickiness is not enabled. So if you need to enable it, you have to click here. So as you click here, now the stickiness on this load balancer has been enabled. But we have two type of stickiness here. So means from where actually you will maintain the cookie. Either you have an application which is well configured to maintain the cookies. In that case, you will choose application based cookies. If your application is highly configured for the cookies, you can choose this option. But in my case, because I was using very simple application, I don't have any code to manage actually or to see the application based cookies. So I'll choose this load balancer generated cookies. So here the load balancer will take care about those sessions. Load balancer will take responsibility to maintain the session with a specific server during the time you specify here, and this is known as stickiness duration. I told you, so this duration can be in seconds, can be in minutes, can be in days. So minimum stickiness duration is 1 second and maximum is 7 seconds. So let's say I'm taking in minutes. Let's say I'm taking 5 minutes. So if you take 5 minutes to make transaction, I think 5 minutes are sufficient. So if you go little down, you can just save the changes. If you save the changes, what will happen? So now the stickiness is on. And if you go back to the same URL, and if you keep refreshing, you will find this will change, but it will take time. Now you are maintained, your connection has been maintained on one server, and it will remain here for next
5
5
minutes.
minutes. 5 minutes, right? It's not mean that the load balancer is not working. Load balancer is working, but because of that stickiness session, that session is maintained on a particular server on particular machine, right? So this way you can configure. And if you go back again, you can just make it off. How you will make it off? This is a target group, and here we go, and you can just add it, and you can remove this. I don't need, for example, I don't need this, and you save the changes, and again in a few seconds you will see that it will start working. That will take a little time because there's a configuration change. So I think that the first, yeah, now it is working. Great. It takes time. That's working again, right? So this is the one thing. The second, the most important thing, this is I did write everything about the stickiness. If you read, it will help you. You have not to read much. I think the objective should be clear. So what are the advantage of using stickiness? It improves the performance because your session is maintained to a specific server. It provides the connection consistency. Stateful applications are using and easy to implement. So these are some basic things. Next is, let's say, cross-zone load balancing. This is another way to distribute your load. So this can be explained with the help of cross-zone load balancing. So cross-zone load balancing is a feature in elastic load balancing. Then how it will work? See, and what it will do. See, for example, this is a feature. If you keep this feature on, if you keep this feature enabled, what will happen? Assume that you have 10 instances in your target group, right? And out of those 10 instances, 2 instances are running in availability zone 1 or availability zone A, and rest 8 instances are running in availability zone B. And this is the load balancer. For example, this is the load balancer, right? And this load balancer, what this will do, if this feature load balancing is enabled, so means each and every machine will get equal amount of traffic, and each of the 10 target receives 10% of the traffic. Means each and every machine will have equal amount of traffic. And this is because the load balancer node can route 50% of client traffic to all targets. For example, it will not see that where your machine is. Your machine can be in availability zone 1 or availability zone 2. But if this feature is on, cross-zone load balancing is enabled, so whatever the traffic is coming, one by one, it will send all this traffic equally to all instances, right? So it will not see where is your instance is, where is your instance is. So this way, it is distributing. So every machine will have a 10% of the total traffic. Correct or not? Now, but what will happen if you disable this feature? Let's say in this case, you have, again, I'm taking the same case. You have 2 machines in one availability zones and 8 instances are in availability zone B. And you you disable this feature. If you disable the feature, it means you are not sending equal amount of traffic to all these instances. You are distributing equal amount of traffic to these availability zones. The 50% traffic will go to this availability zone and 50% traffic will go to first availability zone. And this way, this machine will get 25% of the total traffic and 25% here. And here, every machine will have only 6.25% of traffic. Just understand. So you are not distributing equally traffic to instances, you are distributing equally traffic between these availability zones. So it depends on your use case. So what is suited most to you? You want to enable this option. So by default, this is enabled, right? And this is a good thing because every machine will get equal amount of traffic. But in some cases, if you see that I don't want to send equal traffic to all instances, I want to distribute my traffic to basically on the basis of availability zone. In that case, you can use this option. You can disable this cross zone load balancing. And here in the configuration, from where I can see, so again, this is a target group and this is the attribute. And if you edit it, you can see, do you have any option? Yes, I have option called cross zone load balancing. By default, it is enabled, but we have 2 options here. One is off, one is on. So if you switch it off and you save it, it means in this case, this cross zone load balancing is disabled now. And when it is disabled, what kind of a nature and how actually the load balancer will behave, that you should know, right? So going back, and if you don't need anymore this option, you can remove this option and you can set it on, or this is the default. This is the default one. Save the changes. So these are the few things available. And now let's talk about the health check. So in the health check, let's say this is the health check. So right now we have multiple options in the health check. This is a target group. You select your target group, and in the tab health check, you click on edit, and we have a number of options that you will see in advanced health check setting. So we have multiple options available. So what all these are options? The first of all, health check is on the basis of port number or traffic port, or you want to override it. So if you want to use any other port, you can specify the port here. But it is okay because my port was selected and we have healthy threshold. How actually load balancer will declare that your instance, target instance is healthy? So it says that every load balancer will send heartbeat packets or means test packets to your endpoints or your healthy instances. And if the 5 consecutive packets response are good, in that case, load balancer will declare that this instance is healthy, and it will start sending all the requests to healthy instances. So this particular number of consecutive health check can be changed between 2 to 10. Let's say I'm doing here 3, right? 3 is okay. If 3 consecutive packets response is good, it means the load balancer will consider that this machine is healthy, and now I can send packet to this particular instance. And on what circumstances, on what particular condition, actually health check will declare that this machine is not healthy. If 2 consecutive packets are dropped, if 2 consecutive packets sent by the load balancer to the machines are dropped, it means that machine is not working. And if the machine is not working, the machine is not responding, it means that machine is unhealthy. It will declare that this machine is unhealthy, right? That protocol is not working, that protocol is not responding to load balancer. So load balancer will declare that this machine is not healthy. I'm not going to send any traffic or any request to that particular machine. It will not send any request to that particular unhealthy machine. And second is timeout. What is a timeout? Because once the load balancer sends the traffic or a request to that endpoint, so it will wait for 5 seconds here, right? It will wait for 5 seconds. This is default setting, I'm telling you, because this number can be changed. This number of seconds can be changed. So it will wait for 5 seconds to get response from that machine, right? But in this specified time, if the load balancer doesn't get any response from that machine, in that case, it will consider that the packet has been dropped, right? So this can be changed. And this is the interval. What is the interval? So this frequency can also be managed by you between 5 to 300 seconds. Means, and by default is 30 seconds. What is the meaning of this? Means in every 30 seconds, load balancer will send heartbeat packet to your target instance, right? So this frequency can also be changed from here. And this is success code because you are running or you are using either port number 80 or 443. So definitely some web application page or HTML page will be running on those machines. And if your HTTP service is fine and your HTTP page is fine, then only you will get actually the good response on this load balancer. And the good means the successful response code is basically does exist between 200 to 299. Generally, we see that if you're getting 200 code response or 202 code response, it means your page or your service or web application is running fine. And if you're not getting 200, it means something is wrong. It means that machine health is not correct. So load balancer will not forward any traffic to that endpoint. So all these parameters are very simple. You can set, right? So let's say I'm telling you how you can see. Let's say you have multiple machines, right? I have multiple machines and both machines are running fine. And you see that. So I'm getting response from both servers. Is it? So what I'm doing, I'm intentionally taking a remote of one server to stop HTTP service on a specific machine. Let's say I'm choosing web server 0 and I'm just going to connect it, right? I'm not deleting the machine, just understand. I'm not stopping the machine. I'm doing some configurational changes in this machine. And for example, I'm writing sudo sys system ctl stop HTTP. What I'm doing, I'm stopping HTTPD service. So if you are stopping HTTPD service, it means some configuration problem is the machine is there. Machine is healthy. Machine has an IP address. Everything is okay, but the application running on this machine is not responding on this port number because of some misconfiguration, right? So once it is there, you can see the status of the service systemctl status HTTPD. And if you write here, you're going to see this has been disabled, right? This has been disabled. This is not working. This is inactive or dead. You see this line. Just 33 seconds ago. Now, if you run this command again, this number will change. This number will change. Where is that? Where is that one? I'm seeing that. Yeah, here you can see. Now 1 minute, 13 seconds. The time is increased. So from this, you can understand when it was disabled. So almost 1 minute, 30 seconds ago, actually, this service was disabled, right? And if you keep refreshing it, that will take because it will drop two requests. Then your load balancer will declare that this machine is unhealthy. And between two requests, the frequency time is 30 seconds. So means 30 plus 30. You have to wait here for 60 seconds. After 60 seconds, it will take decision, right? Now, I think the 30, 60 seconds are elapsed. So you will get only response from one server. You're not getting any response from another server. Why you're not getting? Because load balancer is responsible to check the health of instances. If the instances are not healthy, load balancer will not forward any traffic to unhealthy machine. And what are the advantages? Because let's say if this mechanism is not working, for example, what will happen? So one request will land on healthy machine and another request will land on unhealthy machine. An unhealthy machine will show error on this page. And this is a bad thing for any user, for your business, right? So you will always get a healthy response because of this feature. Correct?
Yep.
Any question from your side?
Yep.
No question? Okay. So I need to restore that machine health once again. What shall I do? I'll write sudo system ctl and start HTTPD. Right. Here we go. Or you can see status. And you can say this is enable active running just 7 seconds ago. Right. And because of the health check configuration, I configured actually for health check three uh, three times. So means 3 into 9 30 is equal to 90 seconds. So after 90 seconds, so I'll get response from both the machines. You have to stay here. After 90 seconds, it will declare that your machine is healthy and it will start sending a request to both machines. So both machines will respond. But after 90 seconds, because you configured, you provided actually 3 over there. That's not yet over. Responding. 90 seconds are not over. See, your end is working. For me, both machines are working. But I'm not getting response from my second machine. What do you say?
Yeah, it is
Load
getting.
balance.
I'm getting from both the machines.
You're getting both the machines. Okay.
Yep.
I'm not getting here. Let me start this session again. Now everything is okay. It seems incorrect at my end. I'm not getting any response from the servers. These servers. Why? It's perfect. Load balance is okay. Target is okay. Your target machines are initializing. My target machines are initializing. Healthy. Now my machines are healthy. Can I see here? I'll go back. Something is wrong at my end. I don't know why I'm not getting. So
No, it's
let me try on another browser. No, yes, I'm not getting here. Vivek and Jagat, you are getting response?
yeah, I'm
Yep.
getting.
I don't know. I'm not getting here.
Yep, it's working fine.
It's not fine for me. I think some internet issue. Okay. But it says that your machines are healthy. The status is healthy. Secondly, you can also see your machines are running and your load balancer. This is the load balancer is active and this is the endpoint. So you can also configure this load balancer endpoint with a particular domain name. Let's say you have a domain name example.com and you want to access this application not by using endpoint. This is absurd. Really, you cannot share this kind of DNS with your client. So this particular DNS can be mapped with a public domain name like abc.com, example.com. But for that, you have to use a Route 53 service, because Route 53 service in AWS is a DNS service. We will use that DNS service, right? Is it clear?
Yes.
Yeah.
Right. I think this morning time is absolutely correct. So this time, between 8 to 10. So we get up in the morning. First of all, we have a class, and then you can do any other activity. What do you say?
Yeah. Yeah. Right. Yeah. Actually, afternoon again, office starts, so nobody knows if we can have the
Yes,
class in the later evening or not. So
the
I think morning is
daytime is
always better.
the morning is always, and the evening time sometimes you are very tired, you are not in a mood, you have a lot of things in your minds are running. Yeah, that option also is open, because we have to manage everything. But the morning time is more suited, right? It's more suitable. Yeah.
Yeah.
So see, AWS will charge for load balancer, will charge for these EC2 instances. And if you want to see, I don't know, my application, my endpoint is not working. I don't know why it is not working. So this is really, let's say AWS ELB and ELB pricing. If you write pricing, you can see here we have a pricing load balancer. Earlier, this activity was free. Actually, one day what happened, when I saw my charges, I got actually some charges for the load balancer. I was really surprised, because earlier this feature was free of cost. Now I think AWS is charging for these load balancers. And once you configure application load balancer, configuration point of view, application load balancer and the network load balancer, both are identical. Exactly. The only thing is the names are different, purpose may be different, but the step to configure application load balancer and network load balancer, both are identical. Means configuration style is identical, right? And it says that you are charged for each hour or partial hour, because AWS charges on a hour basis, on a minute basis, on a second basis, that the application load balancer is running, and the number of load balancer capacity units per hour. So uh, what exactly is this? This is basically LCU. LCU means the how much the compute resources are being used about the load balancer, because the load balancer is highly scalable, and by default it is highly available component, right? You never configure, you don't have any configuration to maintain high availability or scalability. So by default it is scalable and it is available. And if you have a much load on the load balancer, it means you will use more LCU. And if you use more LCU, you will pay more money to AWS, right? And in the case of network load balancer, you will use NLCU, which is known as network load balancer capacity unit. More the NLCU you will use, more money you will pay to AWS. And this gateway load balance is different. Actually, everything is, it says that the what is free of cost in your AWS free tier account. So actually, EC2 instances are free of cost for 750 hours. And even the load balancer balancing for free with the AWS free tier account. So this is the advantage using AWS free tier account. So means AWS will not charge anything for any LCU or any NLCU for free tier account. Correct. But if you need to understand more about application load balancer, so these are some references are given, some information are given. Let's say 0.0225 per application load balancer per hour, and in addition 0.008 per LCU, and in addition 0.005 0.005 per hour per trust store associated. I don't know this. I have to see. This is some additional. Okay, this is for the TLS traffic. This is the TLS traffic. TLS traffic, I can understand because you must be using SSL and TLS traffic. So if you are using HTTPS connection, in that case, this some additional charges are there. So you can read actually what details are given, and some scenarios are also given to which will help you to calculate actually the prices of the load balancer, right? So four scenarios are given, right? So this is the link I'm sharing with you. This is the link you can just see in your meeting chat. You can copy this link. You have a little idea about this, right? And the same thing, what I want from you, you please use here network load balance and see what is the major difference you see when you configure network load balancer and application load balancer, and how application load balancer is responding, and how the network load balancer implemented applications are responding to you. That you will tell me tomorrow. What do you say? What do you think?
So,
Right.
Sanjay, from tomorrow, 4 days, we are not available till 11th.
Oh,
5
oh,
days. 12th, we
just a
can.
minute. Can we take one more class today evening? Is it
What
possible?
time?
Just time between 10 and 12. You can spare 1 hour.
Yogat, you are available?
Just checking. Just give me a minute.
If you people are available, if you can spare 1 hour additional today evening, then it's okay. Just ping me, right?
If I have something around 10 o'clock, can you do it before Sanjay anytime possible?
No, no, no. Actually, I have a session between 7 and 9.
Before that, anything around 4, 5, if you are available.
4, 5. Yeah, yeah. I'll update you in that case, right?
Yeah, please.
Little
I
fine.
think I am free from 3:30 to 6. I do not have anything.
And what about Vivek?
Yeah, I am also available.
Okay. Let me see that time I'm available or not. If I'm available, I'll ping and we can start, right?
Yeah.
Sure, sure.
So because I need to start another topic is uh what do you
Auto scale.
say auto scaling. Auto scaling also is important. This is auto scaling. So we'll start this auto scaling. What is auto scaling? Like we have vertical scaling, horizontal scaling. Within the horizontal scaling, we have further some distributions like dynamic scaling, fleet management scaling, and what all these are, what are the features, how you will configure it, and number of features are there. Simple auto scaling, predictive scaling, scheduled scaling. Then we have life cycle hooks, we have warm pools, we have number of options available. We'll talk about all these, right? So one by one. And practically we'll see that how we can configure it. And before leaving this session, so we can do one thing. We do not require actually these instances anymore. So either you can stop them or you can terminate them. So let's say I'm stopping them here. I'm stopping them. And once these are stopped, you can also do one thing. You just delete all these your configuration. So let's say I'm deleting this target group. You go there and delete the target group. And it says that the target group is currently being used. No issue. You can do one thing, go to the load balancer select the load balancer, go to action and delete the load balancer. And to confirm, write confirm. And here we go, delete it. It has been deleted. You can see the load balancer is deleted, but still the target group is existing. So you will not pay anything for such resources which are not being used here, and it is not connected directly with the LCU. So you can do one thing to just keep your, uh, account configuration light. You should delete it. And here we go. So nothing is there. Now in your account, no target group, no load balancer, and no running instances. So these machines are stopped, right? So this is the load balancer, and next I'll start auto scaling. And after that, you are coming back on. So we will have a class on Monday or on Tuesday after this
Tuesday.
class.
Tuesday.
Tuesday. Tuesday is almost after 1 week, right?
Yeah.
Chal, it's okay. So I'll give response, right? Let me check I have time or not. If I'm free, definitely we'll have a class, right?
Sure. Yeah.
Okay, dear. So we are closing the session for the day, and in a few minutes I'll upload the recording of this session.
Sanjay, before you close it, just one question related to this load balancer.
Yeah.
In anything on gateway load balancer, any restriction is there that where we cannot use a gateway load balancer?
We cannot use.
Yeah, is there any
We can use.
limitation?
No,
Like,
no. We can
no?
we can no, no. There is no limitation because the firewall you can implement even on single machine,
Mm-hmm.
standalone machine. You can see the scenario is little different actually, and gateway load balancer is not a part of AWS solution architecting. It's a part of advanced networking. So what
Okay.
happens when you start uh, configuring that load balancer, gateway load balancer? So we must have multiple VPCs, right? We must have multiple VPCs here. And here in the center, I'll use transit gateway. You know what is a transit gateway? This is a transit gateway. It's a little, complex. And these are the VPC. And here you will use gateway load balancer. This is the gateway load balancer. This is the gateway load balancer. Let's say GWL. And here you have your target groups. Let's say this is the one target group and this is the second target group. In these target groups, you have number of machines are running, and the internet traffic will will internet traffic will land here. Just understand. And for these target groups, you will have load balancer. The one load balancer is here, and one load balancer is here. And this gateway load balancer will contain component, and this will filter the traffic. This will basically land on this transit gateway, and transit gateway is directly connected with these two VPCs, right? So this is a little complex. Actually, we are using this gateway load balancer only if you need to filter your traffic. You need to control your traffic. If you want to identify some unidentified threats through IPS or IDS, in that case, you will choose. But your infrastructure will become more rich, more expensive, more rich, more expensive, more complex. That can be done, but later on, but it's not a initial part. So you will use this kind of configuration only with very big applications, right? Those are spanned
Mm-hmm.
on multiple VPCs. You have auto scalings, load balancer. Let's say 100, 200 machines are running or containers are running, and it's very difficult to actually very difficult to actually manage the security concerns. So in that case, the gateway load balancer can be used, because this gateway load balancer can also provide you a kind of a report, and on the basis of that report you can monitor your incoming as well as outgoing traffic and incoming threats as well, right? So definitely we will not use gateway load balancer here, but the gateway load balancer is only possible, your only possibility, if you have a big infrastructure and you want to monitor it, or you want to stop any threats from incoming traffic, then you will use gateway load balancer. So I think you will have some little idea about this.
Okay. So when there is no restriction for any port and or like you have application load balancer only works on STB ports. So there is nothing like that in gateway load balancer, right?
No, because to configure load balancer, you must have a very good experience or hands-on on your third-party firewall. Let's say you want to implement Palo Alto firewall or Cisco firewall. I mean, you should have how to configure that firewall. So you have to configure that firewall manually in the gateway load balancer. Correct?
Okay. Yeah.
So, and if you need a little more idea about all these stuff for some advanced usage, let's say AWS gateway load balancer, the blog is there. Let me see, some architectural diagram is there. No, this is not. Here we go. Here. So can you see? This is the one VPC, this is the another VPC, and this is the internet. This is the internet facing VPC. This is internet facing VPC, and here we have a gateway load balancer. And this gateway load balancer is connected with transit gateway. Do you see here transit gateway?
Yeah.
Yeah, this is a transit gateway. So this is the one VPC which is connected with the transit gateway. In the first VPC, you have gateway load balancer, and here you have your applications in spoke 1 and spoke 2. So these are different VPC where your applications are running. Correct?
Mm-hmm.
So a little complex, but ultimately means if you have a knowledge about transit gateway, if you have knowledge about let's say third-party firewall, you can implement. But you should have a great idea about third-party firewall. Then only you will configure it. So only placing of gateway load balancer will not configure this entire infrastructure. So you have to configure actually that load balancer as well. Okay.
Yep.
So guys, we are closing the session for the day, and if possible, we will have one more session. I'll update you.
All right.
Thank you. Thank you.
Thank you.